Okay, this is week 11, day 2, and this is the second video. There's only 2 videos for this week. Problem 1 is to use the horizontal line test to determine if the function is one-to-one. So this horizontal line test is the exact same as the vertical line test we did earlier. The same rules, except the only difference is that we're drawing a horizontal line to the graph. So the idea is that if you can find a horizontal line that intersects more than one point on the graph, then the function is not one-to-one. If every horizontal line intersects 1 point or 0 points, then it is one-to-one. So let's look at part A. Here we have this graph here, which I've drawn in blue. And I'm going to show, using the horizontal line test, that this is not one-to-one. So all we do is we just draw a horizontal line straight through here. And you'll see that we have 1, 2, 3, 4 intersection points. So 4 intersections for this horizontal line. The horizontal line test says that if you have more than 1 intersection, then it's not one-to-one. So since this has 4 intersections, it's not one-to-one. So graph A is not a one-to-one function. Okay, let's look at graph B. So I'm going to show that this is one-to-one. So you can see this just by draw a few horizontal lines to the graph. So we'll notice that this one has 1 intersection point. If I draw one through here, just 1 intersection point. It doesn't really matter where you go on the graph, it's just going to intersect 1 time. The horizontal line test says that if every horizontal line has either 1 or 0 intersections with the graph, then it is one-to-one. So we have every horizontal line intersects 1 time. Only once. So what this means by the horizontal line test is that this is one-to-one. So this graph for part B is one-to-one. Now let's look at C. Here the graph for C is just a collection of points. And so I'm just gonna, for example, if we draw a line through this top point over here, see it intersects this dot. That's 1 intersection, no problem. And the same thing, if you drew a line through here, you just have 1 intersection. So up here, there's no problem. But if we look down here where we have this line of 3 dots, if I draw a horizontal line through here, you'll notice that it intersects 3 times. So we have a horizontal line with 3 intersections. So this, like part A, cannot be one-to-one. So this is not one-to-one, because it has 3 intersections for a horizontal line. Okay, so let's look at problem 2. So we're going to be given some functions f and g, and our directions are to find f of g of x and g of f of x. And once we've done that, use this information to determine if f and g are inverses of each other. So first, let's find, for part A, f of g of x and g of f of x. So here we're given that f of x is x over 4 and g of x is 4x. So if we want to find f of g of x, let's do this one first. F of g of x. What this means is you go to the equation for f of x and replace every occurrence of x with g of x. So f of x is x over 4 becomes g of x over 4. And now we replace g of x with its equation, which is 4x. So this is 4x over 4. And the 4 over 4 is 1, so this is just x. Now let's find g of f of x. So same idea. You go to the equation for g and replace every occurrence of x with f of x. So this becomes 4x becomes 4f of x. And now we know that the equation for f of x is x over 4. So 4f of x becomes 4 times x over 4. But here the 4 times the 1/4 part, so we have like a 4 over 4 becomes a 1. So the 4's cancel, and we just have x. So what we have is f of g of x equals x, and the g of f of x is x. So how do you determine if two functions are inverses of each other? So let me just write this down here. They are inverses if f of g of x is the same as g of f of x, and they're both equal to x. So this just means if you have f of g of x and a g of f of x are x, then f and g are inverses. And this is exactly what we found here in part A. So since they are both equal to x, they are inverses. So yes, they are inverses of each other. So the second question, are they inverses of each other? Yes. Now let's look at question B. So same questions, but different functions. So we have f of x is 2x plus 1, and g of x is x plus 1 over 2. And so let's first find f of g of x. So we want to find f of g of x. We go to the equation for f and replace every occurrence of x with g. So this becomes 2g of x plus 1. And now we replace g with its formula, which is x plus 1 over 2. So that's 2 times x plus 1 over 2 plus 1. Now here the 2 over 2, so notice that the x plus 1 divided by 2, and we're multiplying it by a 2, so we can cancel the 2's. So we just have x plus 1 plus 1. And x plus 1 is just x plus 2. And so we have for f of g of x that it's x plus 2. Now let's look for g of f of x. So like before, we go to the equation for g and replace every occurrence of x with an f. So this becomes f of x plus 1 over 2. Now we replace f of x with its formula, which is 2x plus 1. So this becomes a 2x plus 1 over 2. 2x plus 1 is a 2x plus 2. So this is 2x plus 2 over 2. And now from the 2x plus 2, we can factor out a 2. So we get 2 times x plus 1 over 2. And so the 2 on the top and bottom of the fraction cancel. So we just have x plus 1. So we have f of g of x is x plus 2. And the g of f of x is x plus 1. But according to this rule I wrote up here, they are inverses only if both f of g of x and g of f of x are equal to x. And this is definitely not true for this example. So for this one, part B, no, they are not inverses of each other. They could be inverses for different functions, but not for each other. So no to the second part of the question. Okay, now let's look at problem 3. So here we're given the functions g and h. We have a g of x is given by this formula, x minus 13 over 5. And the function h is given by this collection of coordinate points. And so when we get to the problem, I'll explain what this means. But first, let's look at question A. We want to find a g inverse of x and a g inverse of g of 8. So let's first find g inverse of x. So here is the routine we go through. So we have this equation for g of x. Our first step is to replace this g of x with a y. So we first have y equals x minus 13 over 5. Now our next step is to interchange x and y. So we're going to replace y with an x, and we're going to replace x with y. So we get x equals y minus 13 over 5. And now we want to solve for y. So to solve for y, we're going to first multiply both sides by 5. So here, to get to the next step, we're going to multiply by 5. So the left becomes a 5x. And the right, if I multiply by 5, this 5 will cancel with the denominator. So we'll just have a y minus 13. And to finish solving for y, we just add a 13 to both sides. And so on the left, we have a 5x plus 13. And on the right, we have a y. And to complete our answer, we now replace a y with g inverse of x. So we have y is replaced with g inverse of x. So we have g inverse of x is equal to 5x plus 13. So this is our g inverse. And now they want us to find g inverse of g of 8. Remember, all this means is you plug in the number g of 8 to g inverse of x. Like this, g inverse evaluated at g of 8. So what is g of 8? We just go over here to this equation and replace the x with an 8. So g inverse of g of 8 becomes g inverse. So g of 8, inside this, I'm going to replace the x with an 8. So we have 8 minus 13 over 5. And so we get g inverse of 8 minus 13 over 5. So 8 minus 13 is a negative 5. So we have minus 5 over 5, which is a minus 1. So we really have g inverse of minus 1. Now, if you replace x with minus 1 in this equation for g inverse, you get minus 5 plus 13. And the minus 5 plus 13 is 8. And actually, you don't even need to go through all of this, because we know that g inverse is the inverse of g. We can use the rule over here that if they're inverses of each other, then so if f and g are inverses of each other, then f of g of x is just x. So we could have avoided doing all these calculations and just use the fact that because they're inverses, g inverse of g of 8 would just be 8. So you wouldn't have to do any calculations. And I'm going to have to erase this here to make room. So the answer to g inverse of g of 8 is that it's equal to 8. Now let me just briefly explain what this notation means for h. So when they have the coordinates minus 4, 7, what this means is that h of minus 4 equals 7. The coordinate minus 1, 8, this means that h of minus 1 equals 8. And the same for the remaining 2 points. They want us to find, for part B, h inverse of 7. So what we're going to do is we're going to utilize this rule here. that if two functions are inverses of each other, so like for example, f and g, then if you take f of g of x, you just get x back. We know that h inverse of 4 is 7, or h of 4 minus 4 is 7. This is from the coordinate point minus 4, 7, means h of minus 4 is 7. So what I'm going to do is take the h inverse of both sides. So I'm going to take h inverse of h of minus 4. And this is equal to h inverse of 7. By the rule we had listed before, since h and h inverse are inverses of each other, this left side is just equal to minus 4. So we have a minus 4 equals h inverse of 7. So our answer is minus 4. And that is a 7. So let's now look at problem 4. So here we're given the functions f of x is the square root of 2x plus 6 with domain minus 3 to infinity. And our directions are to find f inverse of x and state the domain in interval notation. So first we're going to use this fact that I've written here. And that is, so if we have a function g of x, which is of the form square root of ax plus b, and its domain is this interval minus b over a infinity, then the range is the interval 0 to infinity. So if you'll notice, if you were to take in this case, the a is 2 and the b is 6, 6 over 2 gives 3. We have that minus b over a is a minus 3. So we can apply this rule here. So immediately we know that by rule number 1, the domain of f here is 0 infinity. So we're just going to take care of that right away. So we have domain of f. I'm sorry, range of f by rule number 1 is the interval 0 to infinity. And now to find the domain of f inverse, so this means domain of f inverse, we're going to use rule number 2. The domain of f inverse is the range of f. So we know that the range of f is 0 to infinity, so we know the domain of f inverse. So we have domain of f inverse is also 0 to infinity. So this gives our answer to this part where they want to find the domain. So now let's find the inverse. So we're going to go through the same steps as before and start off by replacing f with a y. So we have y is equal to the square root of 2x plus 6. And now we interchange y and x, so we end up with x equals the square root of 2y plus 6. And what we want to do is to solve for y. So we first need to get rid of this square root. To do this, we square both sides. So the left squared is just an x squared. The right squared, since we're squaring a square root, we just get what's under the square root. We get 2y plus 6. And now to solve for y, we're going to subtract the 6 and then divide. So first, let's subtract the 6. So here on the left, we have an x squared minus 6. And on the right, we have a 2y. And for our final step, we just divide both sides by 2. So we have x squared minus 6 over 2 is equal to y. And so we could take this as the answer. First, we're going to want to replace the y with the f inverse. So make more room here. So we get f inverse of x equals x squared minus 6 over 2. And that's an x squared right there. And so you could take this as the answer. You could also do one more step and split this divide by 2 to both of the terms. So you could also write f inverse of x is x squared over 2 minus 6 over 2, which is minus 3. So either of these are acceptable answers. So again, we have the domain of f inverse by 2 is the range of f. And by rule number 1, the range of f is the interval 0 to infinity. So we have the domain of f inverse is 0 to infinity. And going through this routine, we find that f inverse of x is x squared over 2 minus 3. So let's look at problem number 5. We have now f of x equals x plus 5 squared with domain minus 5 to infinity. And like the previous problem, we want to find f inverse of x and state the domain of f inverse in interval notation. So first of all, the domain of f inverse, we apply the same idea here. That by step 2, the domain of f inverse is the range of f. And by a very, very similar statement to 1, you can show or see that the domain, that the range of f is going to be this interval 0 to infinity. So we can immediately just find the domain of f inverse. This is equal to the range of f, which by a very similar idea to the previous problem is going to be the interval 0 to infinity. So that takes care of the first part. So now let's look for f inverse. So first of all, like before, we're going to replace f with a y. So we have y equals x plus 5 squared. For this problem, it's very important that we keep track of the domain. So the domain are all of the x values. So I'm going to write down here to the side that x is greater than or equal to minus 5. Because the domain minus 5 infinity, this just means x is greater than or equal to minus 5. So now we're going to interchange y and x. So y replaced with x replaced with y. So we get x equals y plus 5 squared. Because we interchanged y and x, we also have to interchange it here. So now we have y is greater than or equal to minus 5. And now we want to solve for y. So remember that the equation, a number squared equals another number, has two solutions. The solutions are the plus minus square root of this number. So the solution to y plus 5 squared equals x is y plus 5 equals plus minus the square root of x. So we have plus minus square root of x equals y plus 5. And also keep in mind, we still have that y has to be greater than or equal to minus 5. And so now we want to solve for y, so I'm going to subtract the 5 on both sides. Subtracting on the right just gives a y. And on the left, we have a plus minus square root of x minus 5. And so now we have the problem. And so, of course, we still have y greater than or equal to minus 5. Do we take the plus or the minus square root? So first notice that the square root, it can never be negative. It's always a positive number. We have that the values of y have to always be greater than minus 5. If I chose the minus option, then I would be taking a minus 5 minus another number. So I would end up with y values less than minus 5. If I pick the positive option, then I have a minus 5 plus some number, which will give something larger than minus 5. So by this requirement that y is greater than or equal to minus 5, we need to pick the positive option. So finally, we have y equals the positive square root of x minus 5. And the final step is replace y with f inverse. So we have f inverse of x equals the square root of x minus 5. And so someone might wonder, why did we even have to bother with the plus minus? If I had just taken square root of both sides, we would have had the same answer. Well, the reason for this is, what if someone, instead of domain minus 5 to infinity, gave the domain minus infinity to minus 5? In this case, you would go through the same routine, but the signs would have to be the opposite. So we'd have to have a less than or equal to here, here, and here. And if we took the positive option, then we would not satisfy y less than or equal to minus 5. Instead, we would have had to take the minus option. So for these kinds of problems, it's very important to keep track of the domain and remembering that you have two options for the square root, plus or the minus. So our final two problems I've chosen are 6 and 7. For problem 6, we have the equation f of x equals x cubed minus 8. We want to find f inverse of x. So we're going to go through like we've been doing, replace f with a y. So we get y is x cubed minus 8. Interchange x and y, so we get x equals y cubed minus 8. And then solve for y. So first step is going to be add 8 to both sides. The minus 8 and the 8 cancel on the right, so we have x plus 8 on the left equals y cubed. And if we want to get rid of a y cubed, we just take the cube root of both sides of the equation. So you have the cube root of x plus 8 is the cube root of y cubed. But the cubed root of y cubed is just y. So this becomes y, or the cubed root of x plus 8 is equal to y. And for our final step, you just replace y with f inverse. So we have f inverse of x is equal to the cubed root of x plus 8. So now let's look at 7. We have f of x is the cubed root of 8 minus x plus 2. We want to find f inverse of x. So let's first set, instead of f of x, a y. And this is equal to the cubed root of 8 minus x plus 2. We interchange x and y, so we have x equals the cubed root of 8 minus y plus 2. And now we want to solve for y. So first I'm going to get rid of this 2. So I'm going to subtract the 2 on both sides. So we get x minus 2 is equal to the cubed root of 8 minus y. Now, if we want to get rid of cubed roots, we cube both sides of the equation. So we take both sides to the third power. So we now have x minus 2 cubed is equal to 8 minus y. Since if you cube the cube root, you just get the inside. And so I can add y to both sides and then subtract the x minus 2 cubed. So I'm going to first add the y. So I get y plus x minus 2 cubed is equal to just an 8, since the y and the minus y cancel. And we're going to subtract the x minus 2 cubed. And so these cancel on the left. And so on the left, we just have a y. And we get 8 minus x minus 2 cubed. And to get our final answer, just replace y with f inverse. So we have f inverse of x is 8 minus x minus 2 cubed. So the important thing to remember on these problems is that if you want to get rid of a cube, you take the cube root of both sides. And if you want to get rid of the cube root, you take both sides to the third power. And so here I have picked the practice problems. The first one is your attendance problem. And so what your directions, first of all, are we have the equations f of x is minus 3x and the g of x is minus 3x. You want to find f of g of x and g of f of x. That's one. And two, you want to say, are they inverses or not? So I kind of give you your answers here. So for part one, I just want you to verify that this is 9x. So this is just a practice of function composition. So you should end up with 9x for both of them. And the two are f and g inverses. The answer is no, because if they were inverses, f of g of x and g of f of x would both have to be equal to x. So because of part one, they're not equal to x. No for part two. For question two, I've given you the same thing. You have f of x is 2x plus 3. G of x equals x minus 3 over 2. Same directions as number one. Find f of g of x, g of f of x, and say if they're inverses or not. I'd like you to try number two first. If you get stuck, you can watch my solution. Okay, so I'm just going to go ahead and solve these. So let's first find f of g of x. We just want to replace every occurrence of x in f with a g. So we get 2g of x plus 3. G of x is x minus 3 over 2, so this is 2 times x minus 3 over 2 plus 3. Here, the 2 and the 2 cancel, since one's dividing by 2, the other's multiplication by 2. So we have x minus 3 plus 3. And this is equal to x. So we have f of g of x is x. Now let's find g of f of x. So we just go to the formula for g and replace every occurrence of x with f. So we have f of x minus 3 over 2. F of x is equal to 2x plus 3. So this becomes 2x plus 3 minus 3 over 2. So we have this. The 3 and the minus 3 cancel to 0. So we just have 2x over 2. And 2 over 2 is 1, so 2x over 2 is just x. So we have g of f of x is x. So that's question one. So question two, are f and g inverses of each other? Well, we have f of g of x is x, and g of f of x is x. So what this means, if f of g and g of f are both x, it means yes, they are inverses. Yes, they are inverses of each other. So that's our answer to part two.